All right, welcome back, Warhawks. So Mr. Martin again. We are going to do 2.1. We're going to talk a little bit about logic. A lot of you have used these kind of statements before. You'd use them with your mom and dad. You talk about if I get all A's on my report card, then you can buy me a car or something like that. You've had parents where they offer you something, and we call these if-then statements, and we're going to be talking about them being logic. First thing we're going to talk about is inductive and deductive reasoning. We're going to identify methods of reasoning. We're going to figure out which one is a hypothesis and which one's a conclusion. And we won't be talking too much about the truth tables, but we'll talk about truth values and conditional statements. All right, so inductive reasoning uses specific examples to make conclusions. So this is like patterns. So you study for a test. Your grade is, you don't study for a test. Your grade is lower than when you study. So the next test, you apply what you learned from your observation. So if you are, you see that traffic is a lot better at 3 o'clock, and at 3:30 it gets really bad, then you go at 3 o'clock to help yourself out. That is inductive reasoning, where you're seeing a pattern and you're making a, it's causing you to an action because of something that you have observed. Deductive reasoning is when you use like a general rule to make a conclusion. So we have heard since we were a little kid, righty-tighty. I know some of you still have to throw your fingers up and make the little L to figure out what's your right and what's your left. But there's another saying that says righty-tighty, lefty-loosey. And when we unscrew a screw, sometimes we use that to realize, okay, to the right tightens, to the left loosens. That would be called deductive reasoning. There's a rule. You're using the rule to follow your actions. All right, a counterexample would be something specific that proves a statement to be false or wrong. If you made a statement like, if it's a test, then I get an A. And someone can pull up last week on a test when you got a B, that would be a counterexample. It's just something that says, no, that's not always true. Conditional statements are statements that can be written in this if-then statement. We talked a little bit about that at the beginning. The hypothesis goes with the if. So that example that I said, if I get all A's on my report card, that would be your hypothesis. Your conclusion goes with the then. And we would call that, the then for our example would be, then I'd get a car. So hypothesis, get all A's on my report card. Conclusion, get a car. Now, in math, we also use this with different letters. We have P that represents our hypothesis, and Q will represent our conclusion. And we have different forms. If you actually write it out with the if and P, then Q, remember P stands for the hypothesis, Q stands for conclusion. We call that the prepositional form. But if we have prepositional variables, it's when we use symbols like this right here. And this actually reads as P implies Q. So this would say kind of implies. And the truth value is whether the statement is true or false. So we'll refer to that as the truth value. All right, so here we go. Conditional statement. If I got a 94 on my test, then I got an A. So for this, let's go ahead and figure out which is our hypothesis and which is our conclusion. And right here, this would be my hypothesis. I can spell it. And this right here would be my conclusion. Okay, now, what would be the truth value of this? If I got a 94 on my test, then I got an A, that would be true. So the truth value of that statement would be true. Okay, I'm kind of jumping ahead. Sometimes we want to just get some stuff defined so we understand it. We might use this later on. They're going to introduce it, I think, a little bit later. I just wanted to introduce it now. These are called biconditional statements. This is what happens when a statement is true when You say it the original way. So like the example that we had, just if I got all A's on my report card, then I will get a car. If that is true, if the truth value of that is true, and I can switch the other part, which says if I got a car, comma, then I got all A's on my report card. If that is also true, we can call that a biconditional statement. And those can get a little tricky as far as figuring out their truth value. You got to be very careful when thinking about these, because always and never can be tricky words. That doesn't mean they can't ever be used, but just be careful with those. Make sure that it is always or never. And also, the only way that for you to get a car is not going to be to get A's. So that probably be a false value on the if I flip that. When we flip that, we call it the converse. There's actually a couple different things. We have a converse, contrapositive. We'll probably refer to those. If we do later on, we'll make sure to define those before. But the converse is when you flip the if and the then. So the hypothesis becomes the conclusion, and the conclusion becomes the hypothesis. So in our example here, if I did this one and I did the converse, it would, I got an A, then I got a 94 on my test. And actually the truth value of this one is false, because just because you got an A does not mean you got a 94. There are other ways of getting an A on a test. You can get a 96 and you would still get an A. So the truth value of the converse for this one, remember flipping the conclusion, which came to right here, and flipping it the hypothesis. The truth value of this one would be false. So I cannot write this as a biconditional statement. And the way that we write that is you'll see these words, if and only if, and that will tell you it's biconditional. Not sure we'll get into that too much, just wanted to kind of preview it just in case we come up to things like that. All right. Sometimes in the book you're going to see them want you to write the if as the given, then write the then as the proof. So we're going to be doing these things called proofs. We've kind of talked about that, or we'll talk about that a little bit more in our next sections. But the given will be like the if. So it's given means I'm telling you this is true. Just take my word for it. I need you to get to the other part. I need you to prove, based on what I've given you, I want you to prove the then to be true. All right, so for this one, if I was doing this, the given would be I got a 94 on my test. I'm not going to write the rest of that. And then the proof would be I got an A. Now, this is not the best example for us to be using this, because we would not write necessarily a proof for this. But just to give you an idea, that's what the book is going to be talking about when they ask you to do this. Alright, so another example would be if BD bisects angle ABC, then angle ABD is congruent to CBD. So let's draw this out in a picture. And actually, here we go. Let's do the given. If they asked us to do this in the given form, the given would be this part, the if. So given BD bisects angle ABC. And now we know that for it to be bisects, it means that it's going to cut it into two equal parts. We have to prove angle ABD is congruent to angle CBD. We're going to get into how to prove that, and what it actually looks like as far as you're going to get these 2-column proofs. We're going to do that in the next lesson. There's things called flowchart proofs, and there's also a paragraph proof. We're going to get into that in the next section, but this is just how to take a if-then statement and put it into a given and a proof form. You might have to do that on some of your homeworks. And that's going to be it for this section. I hope you have a good night, guys, and try to keep this video short. Talk to you later.